These are two parallel lines. Okay, you can I'm written here L and M. Okay, these are two parallel lines. Okay, now okay. Here you are having two parallelogram. One parallelogram is your A B Q P. Okay, and the next parallelogram that you have P Q R S. Okay, you can see the base is same. The base is same. That is PQ. On this same base, we have drawn two parallelogram. Yes, the one parallelogram is ABQP and one parallelogram is PQRS. Okay, the base is same, and they both lie between the same parallels. The same parallel L and M. Okay, between the same parallels. Between the same parallels, what does this mean? That the vertex that are opposite to this base. Okay, PQ. Okay, the two parallelogram are on the same base. The opposite vertex of this base should lie on the line that is parallel to this PQ. Okay, PQ lies on M, and the vertex opposite to P is S, that is lying on the line that is parallel to M. Okay, the vertex Q opposite to the vertex Q, the vertex is R, that is lying on the parallel line L. Okay, similarly, AB is also lying on that same parallel line. Okay, to understand better, just to give me a 1 minute. Just okay. So now to better understand that, I'm telling you what you can say it's not between the same parallel line. Okay, now if I'm drawing a diagram like this, okay, and I've drawn one parallel like this, and the other parallel is like this. Sorry, I need same base. Now, PQRS is on the same base and ABQP is also on the same base, but they are not between the same parallels. Okay, you can see AB is not on that same parallel. Okay, it is just slightly below, or you can say it can be slightly above also. Okay, so it should lie on that same parallel line. Okay, between the same parallel lines. Okay, so this is the parallelograms. Okay, the figures you can say that are between on the same base and between the same parallel lines. Understood what that means? Because we'll be using this to prove that the parallelogram that are on the same base and between the same parallel lines are equal in area. The triangle and a parallelogram that is on the same base and between the same parallel lines are half of the triangle is half of the parallelogram. Okay, these type of result will be proving. Okay, area of parallelogram on the same base and between the same parallel. Okay, now we are saying that. Now here comes your first theorem. Okay, that is very important theorem. Okay, parallelogram on the same base and between the same parallels are equal in area. Okay, the parallelograms that are between that are on the same base and between the same parallels are equal in area. The area will be equal, but here the condition is that it should lie on the same base. Okay, you can see here in the diagram that the base is same, that is DC. Okay, and the parallel lines is DC and PB. DC is parallel to PB. Okay, and you can see all the vertex opposite to DC are lying on the same parallel line. Okay, understood? So the area of the, yeah, what are the two parallelogram that you see in this diagram? Let me copy it and make it in large. Okay, now what are the two parallelograms that are visible here? One is PQRS, okay, PQCD, this one, and another is this one. Okay, these are the two parallelograms here. So what is given here? That DC is the same. See, I've already written here two parallelograms are given, that is ABCD and PQCD. Okay, two parallelograms are given and this base is same DC and they are between the same parallel PB and DC. Okay, and what we need to prove that the area of the parallelogram PQCD is equal to area of parallelogram ABCD. Okay, this is given and this you have to prove. Okay, now how can we prove? Now tell me, see, if you see the figure very clearly, the area of the parallelogram, in area of the parallelogram PQCD and in the area of the parallelogram ABCD, this portion is common. Yes, am I right? We need to prove that the area is equal. So this area is common in both the areas of the parallelogram. Am I right? Yes. Now, if we need to prove that the area of the parallelogram equal, so what if we prove this and this area are this and this two triangles? You can see these are two triangles. If these two triangles are congruent, that means the area will be also equal. So if the area will be equal, so we can say because this parallelogram is the sum of this triangle and this trapezium. Okay. Similarly, the parallelogram ABCD is also the sum of the common area and the trapezium and the triangle. Okay. And if we are able to prove that the two triangles are congruent, so we can say that the area of the parallelogram are equal. Yes. Any doubt?
No, ma'am.
Arham, Ridhima, Advika, any doubt? So
No,
tell me how we can prove that the triangles are congruent. Okay. Now in triangle PDA and triangle QCB. Okay. Now how can you prove that the two triangles are congruent? I'm just erasing their two different colors so it is properly visible. Now, how can you prove that the two triangles are congruent? We can say that this angle is equal to this angle. Yeah. By because this PQ is parallel to DC. Sorry, not PQ is parallel to DC. PD is parallel to QC because it is a parallelogram, part of the parallelogram, and their opposite sides are parallel and equal. So PD is parallel to QC and PB is a transversal. So they are co-interior angles. Yes. So angle DPA is equal to angle CQB. Okay, co-interior angles. Sorry, Advika, do you want to say something?
sorry.
Thinking, yeah, corresponding angle. Similarly, we can say that this angle is equal to this angle. If you see the parallelogram ABCD, so AD is parallel to BC. Okay, opposite sides of the parallelogram are parallel. Okay, so AD is parallel to BC, and PB is the, you can say, the transversal. Okay, so angle DAP is equal to angle CBQ. Again, corresponding angles. Okay. Now, two angles we have already taken. Now we need a side. You can say this side PD is equal to QC because it is a you can say opposite sides of a parallelogram. Opposite sides of a parallelogram are parallel and equal also. Okay. So in similarly, you can take AD and BC also. Okay. So I'm taking PD is equal to QC. Yes, sides of a parallelogram. Therefore, triangle PDA is congruent to triangle QCB. Okay, from AS rule. Okay, understood? No doubts. Okay, so two triangles are already congruent. We have proved that the two triangles are congruent. So now area see, we have proved the two triangles are congruent. Therefore, area of triangle PDA is equal to area of triangle QCB. Am I right? Yes.
Yes, ma'am.
Okay. Now, if we can see, you have studied in Euclid's only. Okay, and we know that if we are going to add same thing on both the side, so it will still be equal. Yes. So I am going to add the area of the trapezium AQCD on both sides. Okay. PDA plus area of trapezium AQCD. AQCD is equal to area of triangle QCB plus area of AQCD. Okay. Now, what does this mean? This means PQCD, area of parallelogram PQCD, okay, is equal to area of parallelogram. You always write parallelogram. I am writing the short form ABCD. ABCD. So hence proved. Any doubt? Any doubt till here?
No, ma'am.
Arham, Ridhima.
No, ma'am.
So you will be having many more theorems, you can say, or results based on the same theorem. Okay. Now, always I tell you that when there's a theorem, they generally have, in all the cases, we have the converse of the theorem also. So the converse of the theorem is also true. That is, the converse of the theorem is what? Parallelogram on the same base and having equal areas lie between the same parallel lines. Okay, understood? So if they are on the same base and the areas are equal, so they are actually lying between the same parallel lines. Okay. Now you can see here. Wait, some clarity. Corollary. So what does that mean? Corollary, that we have already derived the theorem. We are going to already which has been already derived, which has already been proved. We are going to use the result to show some other results. Okay, so that is called corollary. So what is here the statement? The first statement is, if a parallelogram and a rectangle are on the same base and between the same parallel lines, then they are equal in area. Can anybody tell me this statement? Can the statement be correct or not? If a parallelogram and a rectangle are on the same base and between the same parallel lines, then they are equal in area. We have already studied the theorem, okay? And we have studied in parallelogram also something. That's why I'm asking. We have which theorem we have covered right now? That the if two parallelograms are having the same base and they are between the same parallel lines, then the areas are equal. Yes.
If it's done by ma'am, I think it should, because
Yeah, because
in a
rectangle is
rectangle
also
also it's a
a, yes, rectangle is also a parallelogram. Okay, so if rectangle is also a parallelogram, then we have already seen the theorem first. Yes or no? That two parallelogram with the same base and between the same parallels are equal in area. So we are actually using the result of the first one and proving this. Okay, it is just, instead of saying parallelogram, it is said rectangle, because rectangle is more, you can say it is having more features. Okay, that only we can say na, that every time you see a new technology, they are like iPhone only. So every time a new model comes, it is having some extra feature. So parallelogram is the back one, and the rectangle is having more features, that they are all the four sides. Here also opposite sides are equal. Obviously, it is a parallelogram, opposites are parallel, but the angles are also 90 degree. All the angles are also 90 degree. Okay, but it is a parallelogram. Okay, so you can see the proof is also here, that area of the parallelogram ABCD. Sorry, since rectangle is a parallelogram, therefore from theorem 1, we have proved that area of parallelogram ABCD is equal to area of rectangle ABEF. Okay, so if this type of questions come, so you can easily use theorem 1 and mention that rectangle is also parallelogram, and you can prove that the areas are equal. Now, area of a parallelogram is equal to base into height. Okay, you have been using this from before, that the area, because we have been taught that the area of the parallelogram is what? The formula is base into height. Okay, but how we knew that it is base into height? So you can see here, it's a proof. See, in the figure, we have given a parallelogram. Okay, so parallelogram is what? ABCD. Any doubt around? Okay,
no,
so we have a parallelogram ABCD. Okay, now we need to prove that the area of the parallelogram is base into height. Okay, so what we are doing, we are actually constructing another, you can say a rectangle we are constructing. Okay, ABEF. Okay, we are drawing a perpendicular this one, BE and AF. Okay, you can see here, I have already mentioned construct a rectangle ABEF, because we have already proved that the rectangle, area of the rectangle and the area of the parallelogram between the same base, on the same base and between the same parallels are equal in area. Okay, so we are going to construct ABEF, okay, a rectangle with the same base AB and parallel, and between the same lines, parallel lines AB and CD. Okay, why I'm using a rectangle? Because the rectangle sides are perpendicular to each other. Yes. Okay, so this, they are all perpendicular to each other. Okay, so actually this AB is perpendicular to DC. Okay, and AF is perpendicular to this one. Okay, because height means what? The perpendicular distance between the two lines. Okay, if we are like it is a triangle. If I am talking about the height, so that is the perpendicular distance, the shortest distance between the 2 points. Okay. Similarly, if we are doing two parallel lines or any two lines, okay. So the perpendicular, when you draw the perpendicular, that is the height. Okay. So I'm using a square. Okay. Now, if you see the area of the parallelogram, we have already proved in the theorem what that the area of from Clory first, that area of the rectangle and the area of the parallelogram are equal in area. Okay, they both the areas will be equal. Okay, so I have mentioned here this one. And what is the area of the rectangle? Length into breadth? Yes or no? It is length into breadth.
Yes, ma'am.
So you can write AB into EB. Yes, AB into BE or AB into AF. I'm not using AF. I'm using BE because it is inside the parallelogram ABCD. Okay, so AB into BE. Okay, base into height. Sorry, length into breadth. Okay, so AB into BE. Now this length into breadth will means AB into BE is also equal to the area of the parallelogram. Okay, now here this AB becomes what? This AB becomes the base and BE becomes the height in the parallelogram ABCD. It becomes a height. Understood? Because it is a perpendicular distance between the two parallel lines. Understood? Why the area of the parallelogram is equal to base into height? Any doubt? Anybody?
No, ma'am.
Okay. Razi is not here, na? His exams are still going on.
Yes.
Now we are having this parallelogram with equal bases. Okay. Now till now we have seen on the same base. Okay, on the same base and between the same parallels. Okay. Now the base are not the same, but the base are equal. Actually, it is something like same only. Okay, because same base and equal bases. We'll see here how we are going to prove that. Okay, but the difference is that here the parallelogram with equal bases. Okay, it will not be same. It was equal bases between the same parallels are equal in area. Okay, you have to prove that the two parallelograms are equal in area if they are lying in on the between the same parallels and whose bases are equal. The base are not same, but the base are equal. Okay, I'll just copy this.
Hello.
Yeah, Vika, what happened?
Yes, ma'am.
Yeah.
Ma'am had dropped out due to an internet issue. Can you repeat what you just said?
Okay, from where you dropped out, Advika?
What, ma'am? Ma'am?
Till where
But
you were
ma'am,
there
this was
means
question.
area of the parallelogram is equal to base into height. Okay, I'm repeating here that the area of the parallelogram, area of parallelogram is equal to base into height. Okay, how can we say that? Given is here parallelogram. Okay, so we can draw a parallelogram. Okay, PQRS. Okay, now we need to prove that the area of this parallelogram is equal to base into height. Okay, so what we are doing some extra construction. We are drawing a rectangle. Okay, from the same point P and Q means same base. Okay, on the same base and between the same parallels. Okay, we are drawing a rectangle that is ABQP. Okay, now from theorem 1 or from we can say 1. Okay, area of rectangle. I'm not writing complete rectangle, just rectangle. ABQP is equal to area of parallelogram PQRS. PQRS. Okay. Now area of rectangle ABQP will be equal to length into breadth. Okay, which is equal to length I'm taking PQ into breadth I'm taking BQ. Okay, into length into breadth. Okay, which will also be equal to, so area of parallelogram PQRS will also be equal to PQ into BQ. So PQ is what? It is base and BQ is what? It is height. It is a perpendicular distance between the two parallelogram. Okay, because the square, all the sides of the rectangle are perpendicular to each other. They are 90 degree. Na? In square, whenever you draw, all the angles are 90 degrees, so they are perpendicular to each other. Okay, again Advika left over. I think she's facing network issue. Her voice was also not clear. Yeah. Okay, so the area of the parallelogram PQRS is equal to PQ into BQ, which is base into height. Okay, now let's move to the last one, or not last one. Okay, now here we have to prove that here you can see the two parallelograms are here, that is EFGH and ABCD. Okay, and the base is different. Okay, the base is different. If we write here given, so in given what you will mention, the two parallelograms. Okay, the two parallelograms are here, ABCD, parallelogram ABCD, and parallelogram EFGH. EFGH between same parallels, same parallel lines, and base is what? EF is equal to AB. Okay, so they are between the same parallel lines, and the base AB is equal to EF. Okay, now we have to prove what we need to prove, that the area of the parallelogram, both the parallelogram are equal. So area of parallelogram ABCD is equal to area of parallelogram EFGH is equal. Okay, now how can we prove? Now before that we need to do some construction. Okay, what construction we have done here? You can see we have drawn a perpendicular line from E to the DH. Okay, GH. Okay, we have drawn a perpendicular line from E to GH. Okay, which is meeting the GH as at N, and we have drawn a perpendicular from B on DC. Okay, for the height. Okay, for knowing the height. Okay, because the area of the parallelogram are base into height. Okay, so we have drawn the perpendiculars. Okay, so just mentioning, draw BM perpendicular to CD and EN perpendicular to GH. Okay, now prove. So how can you are going to prove that? You can see here, since EN and BM are perpendicular between the same parallels. Okay, they are perpendicular between the same parallels, therefore EN will be equal to BM. Yes or no? Any doubt? EN and BM are between the same, they are perpendicular between the same parallels, so they will be equal. Okay, if it was not perpendicular, then we cannot say that they are equal in length, but since they are parallel, since they are perpendicular, so they will be equal. Okay, see, if I'm drawing the two parallel lines, okay, and I'm making any line, so can you say that these two lines are equal in length? We cannot say. Okay, because how much it is slant. But when we are talking about perpendicular line, that will be the shortest distance between the two lines, so they will always be equal. Okay, so EN is equal to BM. Okay, EN is equal to BM. You can mark it first. Okay, as they are perpendicular between same parallels line. Okay, understood? So they are equal in length. Okay, why I'm writing? Let's see here. So what will be the area of the parallelogram ABCD? So area of parallelogram ABCD will be equal to base into height. So base is AB into, and height will be BM. Yes or no? Okay, now I'm taking this as second. Okay, and this how we have mentioned from the corollary second. Okay, you can mention here. Now area of parallelogram EFGH is equal to, base will be EF into height will be EN. Okay, yes. Now instead of EF we can write AB into EN. Now how? AB from this. In fact, you have to mention this as first. This I'm mentioning as second, and this I'm mentioning it third. Okay, so from first. Okay, so from first AB into EN, because we already know it is given in the question that the bases are same, they are equal. So EF is equal to AB. So instead of EF, I am writing AB. Okay, now from third, see okay, from second, EN and BN are equal. Okay, so I can write here BM. Yes, from second. Yes or no? AB is equal to BM. Okay, now this you can make it as, so from you can say this, you can take it as 4 from third and fourth, area of parallelogram ABCD is equal to area of parallelogram EFGH. Understood? Any doubt? Anybody?
No doubt.
Didima, any questions? Okay, so understood. When the bases are same and they are on the bases are equal, not same, the bases are equal and the parallelogram are between the same parallels, then the area will be equal. Okay, if the bases are not same, we cannot say it that the areas are equal. Either if they are equal, the bases are equal, or the bases are same and between the same parallel. Now try this example, try it, then I will tell you, because they are just using the result that we have just studied. Just give it a minute to think, and then we will just think about it, how you're going to do it. Okay, in the given figure, ABCD and ABFE are two parallelograms and area of quadrilateral. Okay, they are two parallelograms, and area of quadrilateral EABC is 17 centimeters square and area of parallelogram ABCD is 25 centimeters square. You have to find the area of the triangle BCF. Try this out. Think about it for 1 minute and then I will be telling you. If you understood how you're going to do it, so you can tell me. Shazan, any idea? Nowadays you don't speak. What happened?
Nothing.
Why
Ma'am,
you
can I tell?
speak? Yeah, tell Adam.
First, what we can do is, since we know that CABC is like, it's the common part. So 15 centimeters square minus 17 centimeters square will be the area of ABCE. So, and then we can prove that triangle ADE is congruent to BCF, which means they will have the same area. So BCF will just be the remaining area divided by 2.
But why you need to prove the triangles are congruent, Adam? Okay.
Oh yeah, we don't need to.
See, wait, I'll tell you. You don't need to prove the triangles are congruent. See, we have seen the theorem from theorem first. I'm just writing theorem first. You cannot write theorem first in your examination. You have to mention the complete theorem, because that time there will be so many theorem first. Okay, so you have to mention the theorem first. That is, the parallelograms on the same base and between the same parallels, the areas are equal. Okay, so from theorem 1, area of parallelogram ABCD is equal to area of parallelogram ABFE. Okay, the area of both the parallelogram are equal. Yes or no? Okay, so we know that the area of the ABCD, area of parallelogram ABCD is already given. Okay, now we need to find out the triangle area BCF. BCF, this area we need to find out. Okay, and if you see, the area of ABFE is not given. So from here, area of parallelogram ABFE is equal to 25 centimeters square. Yes, because the areas are equal of both the parallelogram. Okay, now if you see, the area of the parallelogram ABFE is equal to area of trapezium ABCE, yes or no, plus area of triangle BCF. Yes, so the area of triangle BCF will be equal to area of parallelogram ABFE minus area of trapezium ABCE. Okay, or you can say area of quadrilateral ABCF, because area of quadrilateral here it is written. Okay, And we know the area of parallelogram is 25 centimeters square, and area of the quadrilateral EABC is already given 17 centimeters square. So what happened? Okay. So area of your so area of the triangle will be equal to 25 minus 17. That is 8 centimeters square. Any doubt, anybody? Understood?
Yes, ma'am.
So let's try on the next question. Similarly, just give it a minute to do this question also. Okay. Okay. Now think about this question and tell me. In the given figure, it's given that ABCD is a parallelogram. Okay. ABCD is a parallelogram, and AE. So what is given here? Given ABCD is a parallelogram, and AE is perpendicular to DC. So it is the height. AE is the height of your parallelogram, and similarly CF is also perpendicular to AD. So CF is also the height of the parallelogram. Okay. Now what is given as CD is equal to 18 centimeter, and AE is equal to 9 centimeters, CF is equal to 10 centimeters. Now what you have to find? To find AD. Now how can you find?
Give me 2 minutes. I'll just solve this question and tell you.
Okay, just 1 minute. Okay. What is the area of the parallelogram? I'm giving you a hint. Area of the parallelogram. You have two heights, and you know that the area of the parallelogram is what? Base into height. You can have, you can find the area and then put in the next one. Okay, see, let's see. That area of parallelogram ABCD is equal to base into height. Okay, we know that. Yes. Now what we can say, base is what in this, you can say that base is CD.
16, ma'am. Base is CD, which is 80 centimeters.
Yeah, CD, and the height is AE. Yes, ma'am, I have to leave right now. Okay, yeah, Advika, you can leave. In fact, after this question, I will end also because it's already 48. We'll be doing a sign.
Ma'am, height is 9 centimeters.
Yeah, 18 into 9. So what will be the answer? 18 into 9?
Ma'am, it is 128.
What?
120. Oh, wait.
1?
No, I did it wrong.
162.
Yeah.
162 centimeters square. Okay, so this is your this is your area of the parallelogram. Now area of the parallelogram can also be written as what? The new base. The new base, you can take it as CAD. You need to find out AD now. New base we are taking AD, and perpendicular is also given CF. Okay, so now you will be having area of parallelogram 162 is equal to AD multiplied by 10 centimeter. Okay, so AD will be equal to 162 upon 10, which will give you 16.2 centimeter.
Ma'am, we can use one more method.
What one more you can use? Tell.
Ma'am, like the area of parallelogram is B into H, base into H, and area of ABCD equal to DC in CD into A, which is equal to
Wait, Chanan. Slowly you can you speak?
Ma'am, we can like area of ABCD
Yes.
is equal to CD into AE, which
Yes.
is equal to AD into CF.
AD into CF. Yeah.
Ma'am, it will be more easier then.
In fact, I have done the same thing. See, you are equating only, na? You are directly writing here in this one only. Okay. But what I have done, I have just find out the area. Okay. See, proper stepping will be more. The same thing is there. Just what I have done, I have first find out the area, and then I have put the area directly and AD into 10. Okay. Okay. In that way is also the same thing, that area of the parallelogram can be written as CD into AE is equal to AD into what was the CF. Okay, and it will be 162, and it will be AD into 10. So AD will be 162 upon 10. Okay, see, whenever you are solving a question, the steps, how many steps you are going to do to complete your question, that totally depends on your marks. Okay, if it is a 1 marks question, you don't need to go more than 2 to 4 steps. Okay, maximum 4 step, not even 4 step also. If it is a 1 marks question, 2 steps are sufficient, 2 to 3 steps, because on each step you are having 1.5 marks. Okay, and if you get the same question, sometimes it happens that the easier questions you get in 4 marks or 3 marks also. Okay, so you need to exceed the steps. Okay, So it totally depends if this type of a question comes in 1 mark. So you